Pop quiz time! What's the one thing that just about every IoT design has in common? Nope, it's not wireless connectivity. No, not MEMS sensors, but that's a good guess. Nope, not even low-power MCUs. It's people. Yep, that Internet of Things design isn't much at all without us humans, right? But how is our IoT device supposed to know when we're around? I mean, no point having our electronic servants out there serving nobody at all. Knowing when a person is around or how many people are around can really come in handy in our world. Hi, I'm Amelia Dalton, host of Chalk Talk. If you're trying to do an IoT design that requires sensing, infrared technology can be one of the most effective and cost-effective technologies available today. Please welcome my guest, Eric Johnsrud from Panasonic, because today we're talking about GridEye, an infrared array sensor solution that makes present sensing a snap. And before we get started, don't forget to click that link. There you can find more information about Panasonic's GridEye. Hi, Eric. Thank you so much for joining me.
Thank you for having me.
So, Eric, I want to go beyond just motion detection. I want to track direction, count people. What solutions do you guys have for me there?
Oh, we have a very great solution for that. We have our GridEye, which is a thermopile array sensor, which is always looking compared to a PIR, which is looking for a detection event. So the always looking allows it to kind of see a whole image of the area instead of just looking for one detection event. This way you can track people and see where they are.
So how does GridEye stack up against other solutions?
So as I briefly mentioned before, the GridEye is able to track people very well because it has multiple different pixels that all work together to create a whole view of the area. This way you can see motionless objects as well as what direction objects are moving. This helps with measuring temperature in an area as well as thermal imaging.
Now, Eric, how does GridEye actually give me these tracking abilities?
So the GridEye is made up of 64 pixels in an 8x8 grid. So what it does is takes each one of those pixels data and then brings it back into the sensor. You can compare those to be able to see the background versus the objects moving. So this is very good in air conditioners to adjust to where people are, as well as microwave ovens to see the temperature of the food in them, as well as smart lightings and building applications to count and see where people are.
Okay, so can we look under the hood at GridEye?
Sure, yeah, the GridEye has a metal body to help isolate some of the noise out of it. We use a silicone lens that allows the infrared temperature to go through to the IR detector. The IR detector uses a MEMS chip that has 6 thermocouples per pixel, and we have an ASIC inside of there that does a lot of the processing in there. This takes the signal from the thermocouples and converts it to a digital output signal.
So, Eric, how exactly do all of these components work together?
So the GridEye works pixel by pixel, taking that information in, and then amplifying it. We also have 2 thermistors inside of there to use as a reference temperature of the device, which are also taken and amplified in there. The controller then takes all of this information, processes it together to then create an output temperature for each one of the pixels. It then sends it out via I2C. The pixels are only stored for 1 frame, so you would need to do a lot of your processing externally on a microprocessor.
So how good is it at seeing multiple people?
So the GridEye's vision is very good at being able to detect different heat sources as long as they're separated by about a foot or more. This can be seen here on the slides as 2 people walk by each other, and the image is interpolated up in order to see each one of the thermal bodies passing each other.
So how does it know where somebody went?
So on this slide, you can see someone walking into the area, stopping, and then the sensor knows that they stood still for a little bit, turned around and left, so it knows that the room is now vacated.
Okay, cool. So what kind of options are there?
So there are 4 major types of GridEye right now. We have a high and low gain of a 3.3 drive and a 5-volt drive. So the difference between the high and low gain is the different temperature ranges they can detect. So the low gain is -20 to 100 degrees C, but the accuracy is a little bit worse, at about 3 degrees C typical towards the outer pixels, with about ±2 towards the center pixels. The high gain is a lot more accurate of a temperature range. It's 0 to 80 degrees C, and it's ±2.5 on the outer pixels, with ±1 towards the center pixels. They all use about the same current consumption, and they have 3 different drive modes: normal, standby, and sleep. So there's a different frame rate selectable of the sensor, a 10 frames per second or a 1 frame per second, and it all communicates via I2C.
Okay, so are there any different viewing angles that are offered?
Yes, so this normal grid eye is a 60-degree field of view, but we've also made a narrow angle one which is 35.6 degrees field of view. This one is more meant to look at objects that are much closer at it. It comes on a whole board, so it's more of a module device that you would stick into it versus the surface mount version of the standard grid eye.
So do you guys have anything available to speed up development?
Yes, we've created a lot of different software packages to help customers move forward with the design much faster. The two major ones at the top are the temperature deviation and the human detection. So the temperature deviation is the ability to look at two different masses and see what the difference between those two temperatures are to compare the hot and cold values of each one. The human detection, I'll go over in a little bit more detail, kind of shows how we use algorithms to compare background temperatures versus hotspots to identify that it's a person or not and be able to track and locate them. The high-resolution algorithms in the thermal sensation are more towards the automotive side, where the high-resolution takes a grid eye that is swept across an area to stitch together the multiple frames in order to create a higher-resolution pixel map. And then the thermal sensation is looking at the temperature of the person, their clothes, as well as the surrounding area, to assume if they're hot or cold to automatically adjust HVAC systems.
Awesome. Can we take a look at how exactly this works?
Sure. So the human detection demo that we have here uses two grid eyes side by side. We take the raw image and interpolate it up twice to 32 by 32. We then take a still of the background image to use as our comparator and do a difference to calculate what the objects are in the area. From that difference, we then use algorithms to find the center of mass of those heat sources and determine if there's motion, then it's a person. Then that becomes the output on the right side with the red blocks. You can see this all walking as she will come into the room first and sit down, and then he will come in and follow and sit down next to her.
Excellent. So, Eric, where can I go for more information and resources?
Well, we built a very powerful page on our website that has a collection of all of our different white papers, data sheets, spec sheets, as well as our software resources that we have available, as well as documentation and where even to get one of these kits.
All right. And what kind of software have you developed for the board?
So this board, we've developed our TrackMe program, which is a rudimentary tracking program that uses the grid eye evaluation kit. So we take the raw thermal data in there, we do the detection algorithm on it, and then create an output of where the people are. You could also set up different thresholds, such as that line across, to count how many people have gone into a certain area.
Okay, cool. So is there any way that I could get the source code?
Yes, through the process of an SLA, we would open up the source code to any customer that needed this to work with it. All they would need to do is sign this document with us, and then we could provide all the resources.
So have you guys done anything else with grid eye?
Yes, we've actually made a out-of-the-box solution that combines 4 grid eyes and a lot of intelligence behind it to be a plug-and-play solution to do the whole people counting.
So what are the features of that package?
So the features are very similar to the normal grid eye, but it does a lot of the more tracking functionality. So it's able to detect motionless objects as well as moving objects and identify where they are as well as give you the coordinates of that so you know where somebody is or where they're moving to so you can track them. And it also has the ability to measure the temperature of the area.
And how would that be implemented?
So this would be implemented by being installed into the ceilings, then connected to PLC controllers. The controller will then process that data and send it out to either servers to collect it for data analysis, or send it directly to the lighting controllers or AC controllers to adjust the temperature or the lighting.
So could I use this for energy savings?
Yes. So you can see in this example below that there are 2 people on the left side of the building. So we have 100% of the lighting on there and have the AC set to be comfortable there. As you get further away from them on the right side of the building, you see that we have the lights turned off and you're saving energy in that space by even having the AC off.
Excellent. Now, can you show me how the grid eye works and how does it detect people in a space?
Yes, so the unit has an algorithm in to detect the difference between a stationary hot source and a person. So you can see on here that there's a hotspot in front of the person, which is a computer display, and then a server rack in the lower left-hand side. So as the 2 people in the top are moving, you see on the right-hand side the white spaces that represent the bodies with the yellow and green dots inside their center. The yellow dots are it's calculating, and green it has determined a position and will give that output.
Very cool. Well, Eric, I think that's all I have time for today, but thank you so much for joining me.
Oh, thank you for having me. I'm always glad to talk about grid eye.
And before we go, you didn't forget to click that link, did you? There you can find even more information about Panasonic's grid eye. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. Can't miss it, it's right across the top. Or check out YouTube. keyword EE Journal.